Hi class, welcome to exercise 7e, sketching parabolas using the quadratic formula. In this lesson, your examples and pre-learning will be example 11, using the discriminant and x equals minus b on 2a to find the turning point. And your pre-learning for this example will be questions 1, 2, 3 and 4 in the new book and 4, 5 and 6 in the old book. And then we'll do example 12, sketching graphs using the quadratic formula. And your pre-learning for this example will be question 5 in the new book and question 7 in the old book. But before you begin this lesson, please make sure that you've refreshed the quadratic formula. And by refreshed, I mean revised. Now, you probably see why already, but as promised in the lesson about the quadratic formula, the amount of solutions makes a lot more sense when we're graphing a quadratic. Okay, we'll see you in the introduction. The famous quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And this means that a times x squared plus bx plus c equals 0 when x is equal to minus b on 2a minus the square root of b squared minus 4ac divided by 2a, or x is equal to minus b on 2a plus the square root of b squared minus 4ac on 2a. And maybe you can notice that if I was to draw a number line and mark minus b on 2a, then this value of x would be the square root of the discriminant divided by 2a less than minus b on 2a. And this value of x would be the discriminant divided by 2a more than minus b on 2a. And hopefully you remember that the discriminant is that b squared minus 4ac inside the square root. So these two things are the same distance from minus b on 2a. And that is the square root of the discriminant divided by 2a. So using these facts, we can now establish that for y equal to a times x squared plus bx plus c, the x-intercepts are minus b minus everything in the discriminant divided by 2a and minus b plus everything in the discriminant square rooted divided by 2a. And that the axis of symmetry must be x equals minus b on 2a, because the axis of symmetry is always in the middle of the x-intercepts. And another important point on the graph is the y-intercept, which is where we say x is equal to 0. So if y was equal to a times 0 squared plus b times 0 plus c, well, that's just equal to c. So there's one final point that we need to find, and that's the turning point, which we can do now by remembering that the turning point is the point that's on the graph and the axis of symmetry. So of course on the axis of symmetry, the x value is minus b on 2a, and to find the y value of the turning point, we need to sub in minus b on 2a into the quadratic. So in other words, to find that y value, we need to multiply a by minus b on 2a all squared plus b times minus b on 2a plus c. And hopefully you can see I've just subbed minus b on 2a as the x value into that equation. So if I square everything inside the first bracket and multiply the second bracket by b, we end up with a times b squared on 4a squared minus b squared on 2a plus c. And with the a out the front of this brackets, if I multiply that through, it just cancels 1a on the bottom. So we end up with b squared on 4a. And plus minus means minus. And I'm going to multiply the second fraction by 2 on the top and bottom, so we get the same base as the first fraction. And of course, we've still got that c. So I've got 1b squared minus 2b squared, so that's just minus b squared, all on the 4a plus c. So when trying to find the y value in your turning point, you can use this final formula I've got here as minus b squared on 4a plus c. Or you might just find it simpler to sub the minus b on 2a in the formula like we did at the start. Now, as I promised at the start, we'll talk about what the discriminant's properties implies. So remember that the discriminant is defined as b squared minus 4ac. And if you remember back to the block where we covered the quadratic formula, when the discriminant is less than 0, we have no solutions, which is the same as saying no x-intercepts. So that means you'll end up with a graph that looks like this, or a graph that will look like this. When the discriminant is equal to 0, then you're going to have one solution, which translates to one x-intercept. And your graph is going to look like this, or this. And you should remember that this is called a perfect square. And finally, when your discriminant is greater than 0, then we have two solutions, which translates to two x-intercepts. And your graphs will look like this, or this. Okay, so this is the end of the introduction, but we're going to have a fairly challenging lesson today. So I suggest that you pause the video and get on to the building and understanding questions in the new book, which translates to questions 1, 2, and 3 in the old book. And then you can come back for the next section. For the quadratic y equals ax squared plus bx plus c, the discriminant, which is equal to b squared minus 4ac, tells us how many x-intercepts there are. So if the discriminant is negative or less than 0, then there's no x-intercepts. If the discriminant is equal to 0, then there's one x-intercept. And if it's greater than 0, then we have two x-intercepts. And we now know that the axis of symmetry is x equals minus b on 2a. So therefore, the turning point has x value minus b on 2a. And we can sub in minus b on 2a into the equation to find the y value. And finally, the y-intercept is where x equals 0. So for y equals ax squared plus bx plus c, the y-intercept is just c. Okay, let's test all these facts with example 11, where we're going to consider y equals 3x squared minus 6x plus 5. In part A, we have to determine the number of x-intercepts. So for this quadratic, we can see that a is equal to 3, b is equal to minus 6, and c is equal to 5. So therefore, the discriminant is minus 6 squared minus 4 times 3 times 5. So minus 6 squared is 36, and 4 times 3 is 12 times 5 is 60. So we've got 36 minus 60, which is equal to minus 24. So therefore, our determinant is less than 0, and we have no x-intercepts. In part B, they ask us to determine the y-intercept. Well, we know that y is equal to c, and that's equal to 5. Too easy. All right, finally, part C, we're going to find the turning point. So because the axis of symmetry is x equals minus b on 2a, in this case, that's going to be minus 6 divided by 2 times 3, which equals 6 on 6, which is 1. In this case, it's much easier to find the y value by subbing in x equals 1. So 3 times 1 squared is 3, minus 6 plus 5 is minus 3 plus 2 is equal to 2. So therefore, our turning point has an x value of 1 and a y value of 2. Okay, seeing this question doesn't ask us to graph it, let's test it by plugging those values into GeoGebra using this applet. So if you look up the top left here, you can see that I've got input boxes A, B, and C, which are 3, minus 6, and 5 respectively. And this gives us the equation y is equal to 3x squared minus 6x plus 5. And sure enough, we see a y-intercept of 5 and a turning point of 1, 2. Notice down the bottom here, I've added a display of the square root of the discriminant, and sure enough, it ends up being square root of 24, which gives us no real solutions, and that's why we see there's no x-intercept. But I'd like to make one point while we're here by changing a to 1. Now you can see the discriminant is positive, and we have two x-intercepts. Now if I change c to be 9, we now have a discriminant of 0, and we have a perfect square. And you can see that by the way the turning point is sitting on the x-axis. Now, did you notice that the axis of symmetry didn't change? Well, this was because b didn't. So let's do that again, and take notice that the axis of symmetry is x equals 3, and now let me make c 5, and the axis of symmetry is still 3. Now let me make c 9 again, and yes, still x equals 3. But before we leave this applet, just notice how you can enter any value you want for a, b, c, and you'll get any equation that you want. The graph, the discriminant, and all the major points are on the graph as well. So you'd be crazy not to use this. So this link is in the OneNote, and I'll put it in the video description as well. Anyhow, let's go back to OneNote. All right, so let's pause the video now and work on questions 1, 2, 3, and 4 in the new book, and 4, 5, 6 in the old book. And then come back and I'll see you in the next section. For a quadratic such as y equals a times x squared plus bx plus c, we can use the quadratic formula to find all of the key points of this graph. Firstly, we can note that the y-intercept is equal to c, which really isn't using the quadratic formula. But when we find the x-intercepts, we do use the quadratic formula. And they'll be where x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And there could be 0, 1, or 2 possible solutions. And by solutions, in this case, we mean x-intercepts, because of course that's where y equals 0. Now for the turning point, we're going to have the x value minus b on 2a. And as we worked out in the introduction, the y value will be minus b squared on 4a plus c. Or you could sub in minus b on 2a for x inside that quadratic. Either way, whatever works for you, okay? Then we can draw the parabola by marking in all these points. Okay, so let's have a go at that in example 12, where we're going to sketch the graph for y equals 2x squared plus 4x minus 3. And of course, we're going to mark in all the significant points. So we can see in this quadratic, a is equal to 2, b is equal to 4, and c is equal to minus 3. So therefore, the y-intercept is equal to minus 3, and that's easy to find by using c. So as we know, the x-intercept is where x is equal to minus b plus or minus the square root of b squared minus 4ac, all on 2a. And subbing in the values we've already figured out, we have minus 4 plus or minus the square root of 4 squared minus 4 times 2 and minus 3 all over 2 times 2. So obviously minus 4 stays the same, and that square root is 16 minus 24. So that's the square root of 40, and that's all on 4. And because 40 is equal to 4 times 10, we end up with minus 4 plus or minus 2 times root 10 on 4. And we can neaten that up by taking out 2. So we've got minus 2 plus or minus root 10 on 2. So therefore, for our x-intercepts, x is equal to minus 2 on root 10 over 2, or minus 2 plus root 10 over 2. And don't forget our pro tips. We will use the calculator to have a good idea whereabouts that is when it comes time to draw. So let's use the magic of OneNote. So that's around about 0.6. But if you notice what they've done there, they've misread my negative sign. So that's actually minus 2 plus root 10. So the other one will be 0.6. So I'm going to write that in there. And I'll need to rewrite that one to get it right for them. All right, so we got minus 2.6 for that one. And let's not forget the turning point is where x is equal to minus b on 2a, which in this case is minus 1. Okay, so that's minus 4 on 2 times 2, right? Okay, and now to find the y value at that turning point, I'm just going to sub in minus 1. So we've got y equals 2 times minus 1 squared plus 4 times minus 1 minus 3, which equals 2 minus 4 minus 3, which is equal to minus 5. Okay, so let's mark in all those points on these axes. Let's mark in our turning point at minus 1, minus 5, and our y-intercept of minus 3. And we know that minus 2 plus root 10 on 2 is around about 0.6. And minus 2 minus root 10, all on 2, is around about minus 2.6. Okay, so we've got our 4 main points there. Let's try and draw the parabola. Drum roll, please. Close enough. I'm just going to mark those points in a bit darker. All right, so I think I've missed my points there, but you know what I mean. So that's the parabola for y equals 2 times x squared plus 4x minus 3. Okay, and don't forget the pro tip to use the calculator to find the approximate location of the surds that we quite often get for the x-intercepts. All right, so you should really pause the video now and work on questions 5 in the new book and question 7 in the old book. And then when you come back, we'll be able to summarize this lesson. So we now have 3 methods to graph quadratics. They're all related, so use which one suits you best. Make sure that you always mark in the turning point, the y-intercept, and the x-intercepts. The only complication, of course, is if the turning point is the y-intercept and there are no x-intercepts. And in that case, you're going to need one more point to shape your parabola. So yes, horses for courses. Anyhow, in this lesson, a successful student will know the quadratic formula and how it can be used to find the solutions of a quadratic equation, and be able to use the quadratic formula to determine the x-intercepts of a quadratic graph, and understand how the discriminant can be used to determine the number of x-intercepts of a quadratic graph, and finally, be able to use the axis of symmetry rule to locate the turning point of a quadratic graph. All right, so we're coming close to the end of the unit, just 2 more lessons to go. So make sure you do master these topics because it's going to be very important at the end there. All right, I'll see you in the next lesson, whether that's in class or in the next video. Bye.